So this section is multiplying and dividing rational expressions. So multiplication and division are actually going to work the same way as it did before when we had like 2x times 3x. So if you remember, when we had 2x times 3x, we did 2 times 3 is 6, and then x times x is x squared. Same idea. So what we're going to do is negative 2 times 5 is negative 10. And then we'll have root 7 times 2 is 14. 14, just to check, is 2 and 7. Can't break it down. We're done. So same idea here. So when we distribute, we'll have 12 root 10 minus 8 root 16. And then let's check, this is 5 and 2, so we can't break it down. But root 16 is 4. So this will be 12 root 10 minus 8 times 4, or 12 root 10 minus 32. So this is the same idea. We're going to distribute. So root 5 times root 5 is root 25. Root 5 times root 3 is negative root 15. 2 root 3 times root 5 is 2 root 15. And then when we multiply these two, we'll have minus 2 root 9. Root 25 is 5. Remember, there's a 1 here, so when we combine these two, we'll have a positive root 15. Minus root 9 is 3, so we'll have 2 times 3. Or 5 plus root 15 minus 6. And so 5 minus 6 is negative 1 plus root 15. Same idea over here. When we distribute, we'll have 2 root x squared minus 3 root x plus 2 root x minus 3. Notice square root of x squared is x, so absolute value of x. When we combine these two, we'll have minus root x minus 3. So one thing that we need to do from time to time is called rationalizing the denominator. And so what we do is we have to rewrite the radical expression so we don't have any roots in our denominator. So remember, we can always multiply a term by something as long as we're multiplying it by something equivalent to 1. So we don't want this root 5 in our denominator anymore. So let's multiply that by the numerator and the denominator. Notice we are multiplying by 1. So now our numerator is going to be 3 root 5, but our denominator is going to be root 25 or 5. Now on this one, there's two different ways we can go about doing this. Let's start with rationalizing the denominator. So we'd have to multiply both by 2a squared b squared, numerator and denominator. So now our denominator is just going to be 2a squared b squared. Our numerator is going to be 8a cubed b to the 5th, which we can break this down. 8 is 4 and 2, which is 2 and 2. So we will have 2 and then a root 2. And then we'll have an a with one a left over, and a b squared with a b left over, all over 2a squared b squared. And now notice these 2's can cancel, these b squareds can cancel, and 1a can cancel with this, and we're left with root 2ab all over a. Another way we could have done this is to write this as one big fraction, and now notice these can cancel, we're left with 2 in our numerator. Our a's will have 1 in the denominator, and our b's will have 1 in the numerator. So we can rewrite this as root 2b over root a. But now we still need to rationalize this, because we can't have a root in our denominator. And so now our numerator is root 2ab all over a. And notice these are the same thing. So it doesn't matter which way you do it. Another way to rationalize your denominator will be to use conjugates. So notice the only difference here is 1's a plus and 1 is a minus. So you rationalize by multiplying by our conjugate. So for this first one, our conjugate is root 3 minus 1. We have to do it to our numerator and our denominator. So our numerator, once we distribute, will have 2 root 3 minus 2 over. Now when we distribute these two binomials together, we're going to have, I'm going to just do the distribution over here. We'll have root 3 times root 3, which is root 9, minus root 3 plus root 3 minus 1. So these cancel. Root 9 is 3 minus 1 all over 2. Now notice we can factor 2 out of our numerator. These 2's will cancel. We're left with root 3 minus 1. Now over here, the conjugate is root x plus root 2. So now we'll have a lot of distribution going on. So in our numerator, we'll have root x squared plus root 2x plus root 2x plus root 4. And in our denominator, we'll have root x squared plus root 2x minus root 2x minus root 4. So in our numerator, root x squared is just x. When we combine these two, we'll have 2 root 2x's. And the square root of 4 is 2. In our denominator, these will cancel. Square root of x squared is x, minus square root of 4 is 2. We can't do anything else, so we are done.